In the problem, we can see that we have to identify the centroid of this irregular shape, and we know from the basic idea of the centroid that centroid can be identified if we are able to break the given area in number of known shapes, and based on using the information of the centroid of the known shapes, we can identify the centroid of the given irregular shape. So in this problem, if I will see carefully, I will be able to identify that there is a semicircular arc which is exactly not there, which is a cutout. There is a triangle, and there will be a complete rectangular body. So if I'll see carefully, I can identify three different cross section in my problem. One cross section will be this complete one large rectangular body. Then there will be two cutout. One cutout will be of this triangle, and the second cutout will be this semicircular body. And as I know that the individual centroid of all the three sections are available to me, suppose there is a rectangular body of size A and B, and if this is the reference point, I know that the centroid will be at the A by 2 and the B by 2 position. Similarly, in case of a semicircular body, the centroid lies here, and the distance is basic 4r by 3 pi from this side, as well as it is also 4r by 3 pi from the base. Similarly, for a triangle, in case of a triangle, the centroid lies here, where this distance is basically 1/3 of this distance. Suppose this is B, so it will be B by 3. Suppose this is H, then this distance will be H by 3. So based on this, we can identify the centroid, and I generally follow a standard procedure which always help and reduce the error in the problem. And I always suggest my student that what they need to do, first they should make a clear large figure. Once the figure made by the student, I secondly ask student to identify the different cross section. In my case, there are 3 cross section, so I will put the name of this section. Let this larger rectangular body is named by section 1, then the triangle is defined by section 2, and the semicircular arc is defined by section 3. So first job will be make different sections, which I did. The second important step is to make references. In this case, I have considered the extreme left is one of my reference, as well as the extreme bottom is the second reference. Usually I follow the extreme left and extreme bottom, but it is up to you. You can also consider this side as one of the reference, top is one of the reference, but I generally consider the extreme left and the extreme bottom. So now I have made the references. The third condition which I generally ask to the student, that when you made a complete figure, you identify or you mark the centroid of different sections. So mark centroid of known sections. So now I can identify the centroid. One of my centroid will be here, second centroid will be here, and third centroid will be somewhere here. Once you make the centroid, you also mention the distances here, and I know that this is the total distance is 1 meter. So this distance will be basically defined by 4 into 1 by 3 pi. Similarly, the vertical distance of this will also be 4 into 1 by 3 pi. This distance, I can say that I can identify the total distance is 4 here, so this will be 2. The total height is 2 here, so this will be 1. Then for the triangle, centroid lies at 1/3 of this distance. So this is basically, if I will see my figure carefully, I know that the total distance is 3 plus 1 4. So this is also distance 3. So this distance will be, this is 3. So this distance will be basically 1/3 of this distance, so it will be 1. Similarly, I know that this value is 1. So this height or this distance will be basically 1/3 of this, means it will be 1 by 3. So now I have mentioned all the distance or the position of the centroid with respect to the given geometry. And now the next job is to make a table. So here you can see that I have made a table using the given information. In the table, I generally follow a standard procedure. So first I will mention my three sections. This is my section 1, which is the larger one. Second one is a triangle. Third one is a semicircular arc. Then I will put the area. I know that the larger rectangular body has a side 2 into 4. So the area will be 4 into 2. Now I will put the centroid of the individual rectangular body, which is my area number 1, and I know that I have already defined the area centroid on this figure, so it is 2. Similarly, its y position is 1. In second case, I know that the triangle has a centroid here, and I have to write the position of the centroid of this triangle with respect to my reference. I am not going to write the position of the centroid with respect to its own coordinate axis. Students should be very careful when they put this, because sometimes what happens, student directly write the value of the centroid of this triangle 1. No, it is not correct. Since I have considered my references extreme left, the position of the centroid of this triangle will be this distance. So when I will put the centroid value of my triangle here, this will be this distance, and I know that the total distance is 4 and this distance is 1. So the position of my centroid will be basically 4 minus 1. Similarly, if I want to write the position of the y-axis of my centroid, I know that this distance will basically the y bar of my triangle, and the total distance is 2, and the distance of the centroid from the top surface is 1/3. So I know that the position of the centroid for the y position of the centroid of the triangle will be 2 minus 1/3. Similarly, I can write the position of the centroid for the semicircular arc, and that semicircular arc area of the semicircular arc will be pi r square by 4. Its x bar and y bar position both defined by the 4r by 3 pi, and we should always remember this is a standard result. No need to derive this result every time. We should keep in mind that for a semicircular arc, the position of the centroid is 4r by 3 pi from this slide, as well as 4r by 3 pi from this side. So now once I will complete the table, now the question becomes very easy, because I have to simply apply the formula, and I know that in my actual case this is the one of the section in which these two are the cutouts. Cutouts means this section actually not exists. So in my formula, when I will write the formula, I have to subtract the terms corresponding to these two sections. So I am writing that this is a1 into x1, which is for corresponding to the first major section. Then I have to subtract a2 x2 minus a3 x3 divided by a1 minus a2 and minus a3. Sometimes what happens, students forget to put negative sign here, so please keep it in mind. When I will put all the value, I am getting the centroid value for this body is 1.954 meter. Similarly, when I will put the value of in the y direction to calculate the centroid in y direction, the formula again, these two will be with the negative sign in the numerator as well as in the denominator, and my answer is coming out 0.904 meter. So once you calculate the centroid, I always request my student to put the centroid on your actual body and use your intuition that whether this is correct or not, because we have an intuition that okay, centroid will lie somewhere in this area. So I know that one answer is 1.95 and one answer is 0.9. So if I'll put these two value, I know that this is my actual section and these two are my references. So one answer is 1.95, and that if I'll put these two center lines, I know that 1.95. So my one answer is this 1.95 means that means this is the somewhere here, and the second one, so my centroid will lying somewhere here, and if I'll see my intuition, I know that okay, I can understand that the centroid will be somewhere here in this zone. So if I'm getting this answer, it will be correct. Okay, thank you.